So in physics, you know that you got to be careful with your significant figures. Like, for example, you know, if all the data in the question was three significant figures, then the answer is probably three significant figures as well. But there's some exceptions to this simple rule. It's not always quite as straightforward as that, particularly when it comes to squaring. One rule that you might have come across in physics and chemistry is that when you square a number, or I should say a physical quantity that you've measured, when you square it, it loses a significant figure. So the answer is not 1.9881 meters squared, no. Nor should you round it to three significant figures. In fact, the answer is only correct two significant figures. So if you look here, two significant figures, the 8 causes the 9 to go up, which will cause the 1 to go up. So actually, to two significant figures, the answer is 2.0 meters squared. So why is this? Why do we lose significant figure? Why is that the rule for squaring in science? Let's have a look. So suppose, for example, I've given you a square and you've measured one of the sides. You've measured this side, and using your meter stick, you've measured it to be 1.20 meters. But you don't really know it's 1.20 because you're only able to read these three digits on your meter stick. Well, I guess if it's a meter stick, you wouldn't have measured the one, I suppose. So let's make this a little bit more realistic to real life. And let's say you measured it to be 0.80 meters. Now that is two significant figures, and you can't measure it any more precisely. But if you have a really good meter stick with the millimeters marked on it as well, then yeah, okay, maybe you could measure it to three significant figures to the millimeter. But that's really pushing it now. With just a meter stick, you can't really measure it any more than this. So that's three significant figures. That means you're completely unsure about the fourth significant figure. It could potentially be as high as a 9. And you wouldn't know that. You would be completely ignorant of that. But you might protest and say, well, no, it couldn't quite be as high as a 9, because if it was as high as a 9, potentially, then when measuring, you would have rounded up and you would have reported the answer as 801. So then you realize, okay, it couldn't be quite as high as a 9. We're not completely ignorant of this next digit. It's probably as high as 4999, etc., etc., etc. Because if it was more than this, then we'd likely have read it and rounded up to 801. So that's at the top end. That would be a maximum. And by similar logic, you can say, well, okay, I guess it could have potentially been as small as 7, 9, 9, 5, because any true measurement of this value would likely have been rounded up to the value that we saw. If we were to square both of these, let's see what we get. So this one here would be 0.64080025 meters squared. And then the second one would be 0.63920025 meters squared. So your answer potentially is as high as this or as low as this. So what answer do we report? Well, if I report 0.6, I'm actually doing myself a misservice, because I actually know a bit more about that. If I report it as 0.64 meters squared, then that's consistent with the first value here, because if you were to round this off the 2, you would get 6.4. And if you were to round this off the 2, you would get 6.4. So this is consistent with both, and this is consistent with both. But what about the next value? What could we go with? Could we go one more? Well, what would we choose? If I chose 1, then the top one would be consistent. It would, this to 3 significant figures would be right. But this to 3 significant figures isn't right. This to 3 significant figures is a 0.639, and this is a 641. I cannot report a 3 significant figure that would be consistent with the true answer being rounded to 3 significant figures. So I can't report a 3 sig big result that would match the true answer rounded to 3 sig figs. So the best is 2. So you can see the point is, by squaring, you lose a significant figure. You lose one significant figure. You are not as confident in your answer. And I think that's really interesting. It really seems strange, doesn't it? Like, if you have a measurement that's 3 significant figures, it would seem like squaring it should still be 3 significant figures of certainty, of confidence, but no, that's not the case. So that's the explanation. I thought I should make a video on that because I was asked this before.